In this video, I'm going to introduce quadratic functions and go over all of the really important key points on how to recognize a quadratic function, how to graph a quadratic function, and then we'll do an example and put it all together. So these first couple parts here are just really sort of quick overviews of what you need to know. It's going to be a lot easier to understand all this through an example. So I'll try to make this part short and then we'll spend more time just doing an example. So in general, quadratic functions are usually in the form f of x equals ax squared plus bx plus c. A, b, and c are real numbers. A cannot be 0, which just means like that square term has to be there. So some examples, it's possible that maybe the bx and c term aren't there, and that's okay. So 3x squared is considered a quadratic equation or a quadratic function. You could have f of x equals 3x squared plus 5x. You could have, I'll change it up and do g of x equals negative 2x squared minus 4x plus 5. So you could have those three terms like you see there. So it's possible for b and c to be 0. So you only have, one term, two terms, or three terms, but the key here is that you always have to have that x squared term. So whenever you see an x squared in an equation or function and you don't see any other variables with higher exponents than 2, then you know it's a quadratic function. And when graphed, they make, it's called a parabola or parabolic arc, and it looks kind of like a little bit like a U, stretched out U, and it's either opens up. So this is opening up, this first picture, and the second picture is opening down. And they open up when that a, the number before the x squared, is positive, and they open down when a is negative. Okay, and so let's label the vertex, y-intercept, and x-intercepts on the graph below. And actually, I just skipped this part. We need to define what the vertex is first before we label it. So the location on the graph where it changes directions or peaks or bottoms out is called the vertex. It's also the min or max point. So the vertex on the graph on the left is right there, and then we have a vertex here on the graph on the right. And then our y and x intercepts don't, those concepts really are the same as how we talked about them with linear functions. So the y-intercept is where the graph crosses the y-axis. So right there is our y-intercept for that one. And then right here is our y-intercept for the graph on the right. And then our x-intercepts are where the graph crosses the x-axis. So the x-axis is right here. So that's the x-axis, and so we're looking for points where the red graph crosses that x-axis. So right here and right here would be our x-intercepts, and then here and here would be x-intercepts. Okay, so let's move on and talk about some key points, specifically like those intercepts that I just mentioned, how you might find those algebraically. So, just like with linear equations, if you want to find the y-intercept, all you have to do is plug 0 in for x and solve for y. So it's the same thing as what we did with a linear equation. To find the x-intercepts, it's a little bit tougher because, it's harder to solve an equation, a quadratic equation, when we plug 0 in for y. There's a couple of different methods to do it. The method that we're going to focus on in this class is just by using the quadratic formula. So if you want to find the x-intercepts for a quadratic equation, then you're going to use the quadratic formula, which is right here. And I'll do an example in a minute where I show you how to use that. And then to find the vertex, okay, all you have to do is use this formula, x equals negative b over 2a, and then we're going to plug that in to find y. And again, I'll do an example. And then when we graph on Connect Math, the graph is going to open up when a is positive. So we kind of already talked about this before. It's going to open down when a is negative. And then we can locate those key points like the x and y value of the vertex. We can find some intercepts or some other points. So yeah, those are just some suggestions. There's a lot of different ways that you can go about graphing, and so I'm just going to show you some of the quick ways that seem like they work for most students. So let's look at example 1. So we're going to look at this equation, y equals x squared plus 2x minus 8. So this is a quadratic equation, and we are going to work through some steps that allows us to graph this equation. And so step 1 asks us to identify a, b, and c. So what does that mean? Well, it's basically asking us to think about the function notation of a quadratic can sometimes look like this. So we call this standard form. F of x equals ax squared plus bx plus c. So a is the number in front of the x squared, b is the number in front of the x, and c is the number by itself if they are all on one side of the equation like they are here in our example. So let's look through our example and see if we can pull out the a, b, and c values. Now for a, we don't see a number in front of x squared, but if you don't see one, it's like there's an invisible 1 there. So in this case, a is going to be 1, and then it looks like b, that's the number in front of x, is going to be 2, so b is 2, and then c is going to be negative 8. So you always want to make sure that you include the sign in front of the c value, or any of them rather. So if there's a minus sign in front of them, you want to make that value negative. So c is going to be negative 8. Part B asks us, does this parabola open up or down? And so when we're asking this question or answering it, we want to look at the a value and ask ourselves, well, is a positive or negative? So a is positive. It's positive 1. So since it's positive, the parabola is going to face up. Part C asks us to find the y-intercept. So the y-intercept, if we think about the graph, the y-axis is this vertical axis here. So this is the y-axis. And if we want to find the y-intercept, whatever value or whatever point that is, the x is going to be 0 since it's on that y-axis. So we're going to let x equal 0, and we're going to solve for y. So in the equation, x occurs in more than one spot. So we're going to put 0 in for all of those spots. So I'm just going to write down y equals 0 squared plus 2 times 0 minus 8. And so these first two terms just become 0. And we're left with 0 plus 0 minus 8, which is just negative 8. So y equals negative 8. So the y-intercept is going to be 0, comma, negative 8. So that's the answer for part C. And then for part D, we're going to find the vertex, and we're going to use the formula that helps us find the vertex. And that formula is x equals negative b over 2a. That's the x value of the vertex. So we already know what b and a are. We identified those in step A. So I'm just going to go ahead and plug those in. So b is 2, so I'm going to do negative 2 divided by 2 times a is 1. And I'm going to evaluate that. So negative 2 divided by 2 is negative 1. Okay, so we already know that the x value of the vertex is negative 1. And then we're going to plug this negative 1 in for x everywhere you see an x in the equation. So y equals negative 1 squared plus 2 times negative 1 minus 8. Now I'm going to work this out by hand, but keep in mind if you put this all in the calculator, you definitely want to make sure that you put parentheses around the negative 1, especially when you square it, because if you don't, you're going to get the wrong answer. You want to make sure that your calculator is taking negative 1 and multiplying by itself. If you put in the calculator, negative 1 squared, you would actually get a negative 1 as an answer, because what your calculator does is it squares the 1 first, and then it makes the answer negative last, and you don't want it to do that. You want it to actually take negative 1 and multiply it by itself, which is a positive 1. So that's what we're going to do. So negative 1 squared is a positive 1 plus 2 times negative 1 is negative 2, and then minus 8. So if we put that all together, we get negative 9. So the vertex is negative 1, negative 9. Okay. And then E, we're asked to find the x-intercepts. So the x-intercepts, it's a little bit harder. We could do the opposite of what we did in C. We could put a 0 in for y and solve for x. But the problem is when we do that, I'll show you what happens. So we get this. We need some special tools to be able to solve this for x, because x is in more than one location. So a helpful way to do this is to use the quadratic formula. So I'm just going to write down the quadratic formula. So x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So I'm going to go ahead and I'm going to work through this and I'm going to plug in all of these values. So b is 2, negative 2, plus or minus the square root, 2 squared, minus 4 times 1 times negative 8, all over 2 times 1. And then I'm just going to go through and work this out. So I'm going to start by working through this square root. Okay, so 2 squared is 4, minus 4 times 1 is 4, 4 times negative 8 is a negative 32, so negative 32 divided by 2, and I'm going to go ahead and do this one more time, so I get negative, actually I'll come down here, negative 2 plus or minus the square root. 4 minus a negative 32 is the same thing as 4 plus 32, so 36 divided by 2. Now at this point you can use your calculator. You know, sometimes these square roots don't come out perfectly. So in this case the square root of 36 is 6, so that comes out really nicely. If not, you can totally just put that into your calculator. And so what we're going to do 2 of these now. We're going to split them up. And so this plus or minus says do one of these equations or expressions with a plus and one with a minus. So I'm just going to do negative 2 plus the square root of 36, which is 6, divided by 2. And then negative 2 minus the square root of 36, which is 6, divided by 2. So just to highlight here, we're doing one of these with a plus, one of these with a minus, and then you're just going to work through. So negative 2 plus 6 is positive 4, divided by 2 is 2. So there's one of our x-intercepts. And then negative 2 minus 6 is a negative 8, divided by 2 is a negative 4. So our two x-intercepts are 2 and negative 4. And if I were to write those down as an ordered pair, I would write them like 2, 0 and negative 4, 0. Okay. And then my last step, we're going to create a sketch and check with Desmos or a calculator. So for this step, we are going to kind of go through all of our steps and plot the important points that we found. So we know that the parabola faces up. In part C, we found the y-intercept, so 0, negative 8. So I'm going to plot that. So I'm going to go down negative 8 on the y-axis and plot a point. D, we find the vertex. So the vertex of the parabola was negative 1, 9. So negative 1, 9. And then we have two x-intercepts. So we have an x-intercept at negative 4. So 1, 2, 3, 4. I know it's a little hard to see with these numbers. And then we've got an intercept at 0, 2. So over here on this side. And then we need to just connect the parabola. And so graphing parabolas, it's a little bit more involved than graphing a line because you need more than just 2 points because you've got this curve. It's not just a straight line. With a line, if you have 2 points, that's, you know, sufficient. You could have graphed this parabola probably okay if you just had the x-intercepts and then the vertex. Maybe you didn't need the y-intercept. But, you know, sometimes having those few extra points is nice. It makes it a little easier in terms of graphing. Let me show you how you could check this with Desmos, which is an online graphing tool. And you can also use a graphing calculator if you have one. I find Desmos is just really easy to use and it's also free. So if you go to desmos.com, you'll see this, and then you just need to click on graphing calculator. And then if you click on this little keyboard in the bottom left, then you can type in your equation. So I'm just going to type in y equals and then x, and then a squared will make that squared. So x squared and then plus 2x and then minus 8. And then you can use these keys over here to just zoom out a little bit. And then the nice thing about Desmos is if you just hover over the graph with your cursor, you can not only, they show you automatically, they highlight the key points. So they highlight the vertex for you at negative 1, negative 9. So that verifies that we got that right. They highlight the y-intercept of 0, negative 8. They highlight the x-intercepts at 2 and then negative 4. So that confirms all of those points we found were correct. The other thing it does is if you just click on any point of the graph, you can find any point you want. So if you want even additional points, maybe a couple points up top to be even more precise with your graph, you could use Desmos to do that. So it's a great tool to check your graphing work.